Thank you so much. Hello, everybody, and then good morning, good afternoon, good evening, depending on where you are. I'm super happy to be here. Thanks for having me once again. So it's been a while to talk about some of the technical topic with the JCon folks. Since I attended JCon Europe a couple of months ago in Cologne, which is my first time travel to Cologne, which is really awesome, by the way. Okay, so first thing first, so let me share my screen, and then I'm going to go with the Quarkus and the virtual thread and Java 21 topic in the last 45 minutes. Okay, share my screen. Share my screen here. Okay. And then let me try to post slideshow here. Cool. So please chime in, moderator, or like some any the attendees, if you got some feel like some video freezing or audio freezing, and then some of the uncomfortable thing, just let me know. I'm more than happy to address. So who am I first? My name is Daniel. I'm working for Red Hat as a developer advocate, specialized cloud native runtimes, which is Quarkus, Spring Boot, and a little bit about JavaScript, like a Node.js, a bunch of other things. And then I spent a lot of time bringing more the cloud-enabled runtimes into cloud environment, specifically Kubernetes, not only like a vanilla Kubernetes, but also a hyperscaler like Amazon, Google, Microsoft, and Red Hat, IBM, something like that, specifically serverless service mesh and DevOps practices and use cases. I'm also Java champion, and then CNCF, the Cloud and Computing Foundation ambassador for the last 5 and 6 years, which allows me have a lot of opportunities and chance to meet a lot of awesome people, so like developers, platform engineers, and DevOps engineers, and SRE, full stack developer. I've met a lot of people share my experience and knowledge, but also I learned a lot of stuff from them as well. So here's my contact information, Daniel030. You can follow me Twitter, and then now you can say X, and then you can follow and fork my old technical demo example, my GitHub repository, Daniel030 as well. And here's my YouTube handler, Daniel030, what been the URL. I'm gonna bring that up at the last end of the session. You can just follow me here, my book info. You can follow and then subscribe me, and I will be everywhere. Okay, so let's try to understand. Let's take one step back, try to understand what threads in Java works. So if you have some like a long experience to Java application development, like more than 20 years, maybe you probably remember that I was back there like between 1997 and 2000, like a Java 1.3. Something like that. At the time, we have someone Java thread model called that green thread. It's 100% managed by Java virtual machine rather than your operating system, which was cool. So any tightly coupled with the operating system, and so it pretty much managed by your virtual machine, and so no blocking your platform environment. But there are just some issues. So because the infrastructure hardware kept evolving so far, for example, one CPU core evolving to 2 cores and a quad core and even 8 cores. I mean the cores. But in the separately running on Java thread using virtual machine, there's no some relationship with your hardware. So which means even if you full CPU cores, but your Java thread running on one single core rather than multiple core multitasking stuff. So that's Java. We just abandoned and get rid of, oh, this is not cool thread management on JVM. So that's the change, the thread mechanism and model into like a platform thread mechanism, which you keep using that until Java 21 came out. So whenever you running on your Java application, it actually creates a process, and the process running on thread, which is literally your platform thread, which is like an operating system thread, managed by your CPU, like scheduling your thread and running on the memory and context switching, things like that. So this is literally how we using thread on JVM, specifically your operating system until Java 21. So, and then why the thread is matters all the time when you develop your business application, not only like a high concurrent application or microservices or monolith application on the cloud and without the cloud. So previously, traditionally, we have a obvious programming model, which is imperative, aka non-reactive application. You obviously return some of the result, like a data set or some string code, based on synchronized model. Just for example, here, left-hand Quarkus application example, just return some of the process of your business logic and return some string code like a hello world. And then when you see the right-hand side, you have a multiple platform thread. And then whenever you got a new request and the CPU, okay, so I need to schedule your new request running on specific thread, running on some memory managed by CPU. And then, but your application not going to stand all the time. It's most likely called remote services, which is something like a database transaction. We're going to say IO operations, or you can call this some of the external PubSub server like a Kafka cluster, or as a remote server, something outside your app server. Whenever you hit the IO operation or remote services, you need waiting for the result or feedback from the remote service completion. In the meantime, you just hold that platform thread, and then the CPU doesn't allow that platform thread to use another request, because you don't have any one request at all the time. You have a multiple requests, maybe more than 10,000 requests in the next 5 minutes. This is really concurrent application, and you have a multiple use cases to multiple users from like a human being and from around the world and ITO, or there are many kind of end user to access your application. So this we can say the blocking your IO. So for example, the first request reach out to JVM and then try to run your business logic and go to like a PostgreSQL database and then store some of the data. But it takes like a 30 seconds to process the complicated database the schema. In the meantime, the second request arrived into your app server, another user or somebody another web page. And in the case of the first platform thread already assigned for first request, which is still waiting for the return from remote services. So, okay, how do you handle the second request? I'm going to create a new platform thread for the second request. So, but already your infrastructure and the running on JVM is already limited resources to create a platform thread based on your CPU memory capacity. So if you just imagine that, okay, I have maybe 10,000 requests at the same time, each request maybe have an IO operation, like a blocking IO, like a connect to a database. And there is a huge expense to prepare like a big chunk of a memory and the CPU to schedule your thread. So that's why the reactive programming actually came out to solve this non-reactive programming, specifically concurrent application. So you don't need to wait for you don't need to create a new platform thread whenever you got a new request to which have the remote services. In the meantime, so the platform thread in the reactive programming model, they say event loop because you're going to keep reusing the same platform thread like a looping mechanism. So when you got the first request, got to your JVM, and then you're going to waiting for you need to waiting for the response from remote service. In the meantime, the event loop, okay, I'm going to let this platform thread resources to use another request in the meantime. But in order to resume the first request when the remote service is done, I need to remember where should I resume the rest of the job. Like so, I need to save somewhere your status. Where is the callback? So reactive programming call that continuation, that mechanism. So whenever you develop your reactive application, doesn't matter Java or .NET or any kind of framework and platform, you need to implement continuation, such as a coroutine or the callback or asynchronous mechanism, something like that. So with that reactive programming, you just very limited platform thread because you could keep reusing existing platform thread as long as you could create and implement continuation model and a synchronized processing for your application. That's the reason why when you take a look at the left-hand side, the reactive programming sample application on the Quarkus, you can see that a little bit different. You're going to return uni, multi, which is make your application unsynchronized. And also, you need to implement continuation, which is when you take a look at that, the return code line, the asynchronized method is obviously this application processed by asynchronous way. As well as you can add like a .map and then lambda expression, which he implement continuation in reactive programming. If you try to use Spring Boot reactive, you're going to really try to use different ways, something like a Spring Web Blocks, the Mono and Flux, and then you're going to subscribe some of the return code, and then the build the response body as the continuation implementation as well. So the problem is whenever you develop reactive programming, you must not block the IO thread. If you try to block the IO thread, your reactive programming is just ruined. But this is not easy because you need to run something new, every single detail, how to develop unsynchronized application implementation, but also how to implement continuation method in your Java application as well. So here just some bullet point on the what is the advantage or disadvantage or pros and cons for imperative application and reactive application. So imperative application is pretty much easy and obvious to develop your business application. Very simple development model, and they're pretty much expensive. For example, this is a Linux operation environment. You have at least 1 megabyte to create a new platform thread, and there's a 10 microsecond for context switch to scheduling your new request to the new platform thread. This is based on Linux operating system once again. So if you use like a Mac OS or Windows, the number a little bit more higher than Linux operating system. And then also limited concurrency. Is imagine that, okay, I have maybe 32 gig memories, and which means that your maximum capacity is 32, but it's technically not 32 because you need to run operating system and some of the required application like a VS Code or some of the web browser and some of the app server at the same time, which means that you have maybe less than 60% of your capacity or availability of your resources to run and create a new platform threads. Reactive programming. So you have a very small number of platform threads, which is the event loop, to manage the same application concurrency, which is a high concurrency, resource efficient, but pretty much complicated to develop the application because whenever some experience migrate Spring Boot to Spring Reactive, you need to rewrite every single detail. So this is not migration, more like a rewrite whole application. So there's a lot of people, we really want to build event-driven architecture. With that, it's not only like just adopt a Kafka cluster or just adopt Kubernetes, but also you need to redesign existing application, like a reactive application, like a Vertex, like a Java world or Node.js or JavaScript, and then also like a Spring Reactive or Quarkus stuff. So it's a really burden and a big challenge for developer to learn something new with still learning curve. So that's the reason why virtual thread, the project name under OpenJDK, which is a Loom, it just came out to solve this kind of problem. We just combine good thing and just get rid of bad things. So combine good thing from both sides. So keep simple, keep developing simply, and then we gotta have more resource efficiency, and a high concurrent application. So here's a virtual thread, how it works and what that looks like. Just looking at the left-hand side. So we're gonna keep using platform thread. However, we can call that carrier thread because you could understand as a carrier thread, just we're gonna create a new virtual thread and then put into carrier thread, and then just going to the destination, and then your job's done, and we just got rid of that virtual thread, and then we print a new virtual thread into carrier thread basket. That's why we call the carrier thread. So anyway, so it's all platform thread. We just use different terminology based on some of the purposes. So if the event loop is also a platform thread in reactive programming, and then carrier thread also platform thread in virtual thread, the model. So it's a little bit similar concept, and I talked a little bit about at the very beginning, the green thread at back in 1997 and 2000. But at the time, it's managed by virtual machine rather than operating system. So now virtual thread also managed by the virtual machine. It also connects to platform thread, but previously green thread, there's no relationship with operating system. But now you can relate it to platform thread. So that's the we can keep using that. So virtual machine is just managed by your virtual thread. But even if you got some remote services on virtual thread and then you waiting for the response, but the virtual thread, you're not gonna block platform thread, just like an imperative application model. So you don't need to, you could still waiting for response for remote services, but you're not gonna block platform thread. And then in the meantime, the same platform thread allows to mount another request to run another virtual thread. So there is a mount mechanism to make that happen, and how it works the platform thread stuff, and with the virtual thread. And then in the Quarkus application, so there, in order to use a virtual thread, you're going to initialize a virtual thread and then create some factory of a virtual thread and then initiate a virtual thread as well. It's a pretty much a low level of OpenJDK to start initiating and then delete your thread to run your application. But it's not easy for Java developers still. So that's a framework actually provides some more API or some annotation, make it easier and then make it faster. So Quarkus side, so you can just use the one annotation on the method level or class level, run on virtual thread annotation around you run this class or method on virtual thread rather than the platform thread directly. And then the other stuff is all exactly the same. So one thing is, don't get me wrong, if I keep saying, okay, you can keep using, you can keep creating virtual thread whenever you have a new request, and then that virtual thread running on one carrier thread. But I'm not saying you have only one carrier thread. You have a multiple carrier thread, just like an event. You have a multiple event loops, like a platform thread in reactive programming. But there's some hidden secret here. So how do you manage the across multiple carrier thread to allocate it virtual thread in the meantime? So there is actually a fork join based work stealing. So for example, several virtual thread running one carrier thread in the first carrier thread, and then some of the carrier thread already full capacity to process virtual thread. In the meantime, okay, the CPU cores, okay, let me try to create a new carrier thread more increase high concurrency in the still existing like a virtual thread. That thread actually waiting for response from remote services, and then just fork and copy all continuation, just like a similar concept of reactive programming, and then just put it into new carrier thread. And once the remote service is done, and then the second carrier thread just start the continuation, which is store some of the status where I need to resume less of the job, which is store some of the status in the stack memory. Alrighty. So that's the all kind of stuff, the virtual thread, and then how to use, and specifically Quarkus is pretty much easier. So you do simple code snippet, non-reactive application like a blocking application and virtual thread, and then reactive application, also non-blocking application. So the left-hand side is just like a database transaction application, like a to-do, like a store, retrieve, and insert, and delete data. And first of all, this list method, just retrieve all data set from database and sort by order. Pretty much easier. The to-do is your entity class and the list all data. And then when you go to virtual thread code snippet, it's exactly the same method, like a blocking application, but you just need to add one annotation, run on a virtual thread. And the reactive application, I need to rewrite this application using uni and multi. So this is just a very interesting part for the Quarkus who has no experience to use Quarkus before. So Quarkus actually obviously understand how the method treated by reactive or non-reactive, because Quarkus allows developer to implement reactive and non-reactive application at the same time at the same class. So return uni and multi from small right project, like a process your return object as the streaming, like an event-driven application. So uni is a one stream data, a one like event, and then multi is a multiple stream data. When you return, obviously uni and multi, and then Quarkus, oh, this is a reactive application, or you can print the annotation more explicitly, non-blocking annotation, which allows the message treated by non-blocking as well as reactive application. Pretty much is easy. Okay, and then so this really I want to say Quarkus actually analyze the reactive and non-reactive application at build time based on return type or method annotations. Just here's the bottom line. The virtual thread, in order to running on your application on a virtual thread, you have to make sure your application blocking application rather than non-blocking. So with the non-blocking application, you have the fixed number of the blocking application. You have a limited number of workers, like a platform thread, based on your infrastructure, like your laptop, desktop, and a workstation. And the non-reactive application are also non-blocking. You have also the fixed number of event loop. For example, if you like a based on like a CPU cores, like if you have 16 CPU cores, maybe you have a 16 event loop at the same time. So rather than pretty much more number of workers, and then the virtual thread, you just create dynamically as much as possible, like a virtual thread. If you have some experience to use like virtual machine, like Amazon, Google, or even VMware or Red Hat virtualization, you could actually create a virtual machine way more than your infrastructure capacity. For example, I have a 16 gig memory infrastructure, and then I want to create a one virtual memory, 1 gig virtual memory, which means that I'm based on math. Okay, so 1 gig virtual memory, and on top of the 16 gig virtual physical memory, which is like a 16 gig virtual 16 virtual machine on top of that. But it's not true. You can actually create 100 virtual machine, because each virtual machine, you're not gonna use the total capacity all the time. So you can create as many as possible theoretically. So this is a benefit of a virtual thread on Java application. So let me go to the demo, how that works and what that looks like. But for that, here's my Git repo, Daniel030, github.com, and then try to Quarkus to MA, which is literally same demo. You can like a fork and then follow and then give it some star if you want, and then you can just literally replicate this demo on your local machine. All right. So here's my terminal window. Let me check my Java version. Make sure to use Java 21. If you use Java 19 or 20, you could still use virtual thread as a preview feature, which you have to enable like a preview feature on your Java project, like a Maven Palm XML or Gradle module. So I'm going to using OpenJDK 21 today. And then here is my Quarkus application. So everybody, I think everybody see that. Just let me know if you don't. It's quite small, and I'm going to more than happy to bigger. Okay, so first application here is all going to use the parent. So I'm going to use it here, Java 21 today, and then the rest Quarkus version 3.5.2, and then go to first project. I already included some of the dependency, which is like enterprise capability, Hibernate ORM, which is like SQL mapping between Java entity and the actual database. It's the way how to implement the JPA on Quarkus framework, and I'm going to use JDBC PostSQL, and then ORM Panache is pretty much easier to implement data transaction because you don't need to create the getter setter and then like a fundamental operation to restore all data or retrieve specific data or insert data or update data. It's already panache with the ORM, Hibernate ORM integration library already implement that thing. I just need to use the abstract API rather than implement myself. And then I'm going to use Jackson, which is the consume and produce the JSON format code. That's it. And then when I go to like a quick check it out, the Java code, here's a to-do, is my entity. Pretty simple, nothing in there. And then go to resource. And then there are a bunch of the, like I just said there, to-do is entity. And then go back to entity. It actually extend the panache entity and extend the panache entity base. This is exactly what I mentioned earlier. It's all library implement like a persist data, updated data, deleted data, like a CRUD capability. You don't need to implement yourself. Pretty much easier to implement database transaction using Quarkus. And then one of the good things is Quarkus demo automatically start Quarkus runtime on your local machine, which allows you run test container without configuration, like I would say zero configuration. When you go to Palm XML here, and then I'm going to try to like a test container. I don't see that any kind of stuff. And then go to resources, and then I don't have any property here. But when I go back to terminal and then change my directory like a to-do, and then I'm going to run Quarkus dev, and it automatically start the container based on, as you can see, the container automatically download the PostSQL and running on PostSQL data, which is really cool. So when I open new terminal here, let me check the process. Now you can see that PostSQL automatically start. And then when I go to Quarkus demo and then go to dev services, which is automatically set up the required configuration, for example, JVC URL, password, username, and then some of the database generation policy. You don't even remember these all keys and values. You can just copy it back to the application property and change the username and password to override their values, which is cool. Okay, let me go back to here, terminal window, and then this is this is the front end page. So when I go back to one more time, back to the application, I actually added some data in advance. Here's the introduction Quarkus imperative and the Hibernate Panache, and then visit Quarkus website, and then find more Daniel TV. I just explain imperative application Hibernate Panache. And then I just go back to terminal window. When I open the web page, you can see that this application is running on executor thread, which is a worker platform thread directly. And then when I check it out to action item done, and now you can see that two still application running on the platform thread. And then go to Quarkus website, see that this is Quarkus.io. You can find that the latest version. Oh, just so we have a Quarkus latest version here, and then you can find all documentation and all kind of stuff. That's it. And then this is my you can go to Bini URL or YouTube and Daniel 030, and you can find more than more than 100 video around the Kubernetes and Quarkus and serverless function and like a DevOps and the technical team rather than like a deep dive demo. And here's my all conference talk. You can find all that. Yeah, please subscribe and then find and add some inspiration, feedback, and I'm more than happy to address. Okay, so if I try to say that, and then you could keep running on worker thread. If I try to, okay, I'm just this is Quarkus with the broken edge. I just create a new one here, and now you can see that still running on the worker thread. Okay, and I can stop the Quarkus worker thread, and then let me try to change the reactive application. So go back to, just run Quarkus demo again, and then back to the project. And then this is a reactive application. It's pretty much the same thing. However, when you go to application, now you can see that all you need, and some of stuff and then change it to business logic to implement a continuation in a Quarkus application. And now when I go back to landing page, and now you can say a little bit different. Quarkus is reactive, and then reactive power the Quarkus, and then the reactive with the Panache, we also have that. And then go back to a POM XML. Now you can see that we also provide the reactive library as well. Previously Hibernate Panache, now Hibernate reactive Panache, and then Hibernate less easy Jackson and less easy reactive Jackson, all reactive stuff. And then here's a PostSQL reactive PostSQL client as well. And then go back to here. Now you can see that in the running on Vertex event loop, because Quarkus actually builds one reactive engine, which is Netty and Vertex. So previously you can see that it was here, executor thread is a worker thread, and now you can see the event loop. And then go back to web browser. Let me try to done this all kind of stuff. And now keep running on same event loop. If I create a new one, this is a non-broken app. And now you can see that still running on virtual thread, and not the event loop as well. So if I go to another project, like a virtual thread here, and I'm going to run Quarkus once again. And in the meantime, let's go back to just take a look at that virtual thread application here. And then virtual thread application is exactly same application implementation of like a blocking app. But one different thing is I put in here to run on virtual thread annotation. That's it. That's all I needed to do to run this application on virtual thread rather than platform thread. And then go back to reload my front-end application, slightly change the data. What is the project Loom? And then Quarkus integrated project Loom. And then once again, Daniel TV promotion, and then just compare imperative versus reactive. And now you can see that running on virtual thread and number 170. And then when I create just done. And now you can see all the running on new recast to different brand new virtual thread 180, 80, something like that. If you create a new one, okay, this is a really cool demo. And I just create a new one, and then create a new virtual thread to run this new application transaction. That's it. It's not only like a RESTful API, or even you could use like a Kafka integration. For example, I have one Kafka application here, and then Quarkus tab, running on Quarkus tab, and then back to the application. And then here's the Kafka stuff as well. And then go to here, and I put in the same thing, run on virtual thread annotation. And then all application is literally just pops up implementation, how to consume, how to produce the application. So Quarkus application pretty much easier to implement the Kafka integration. For example, here, some of the incoming, outgoing annotation, incoming, really this whole business logic and the return code, and just sending to your messaging broker or Kafka cluster, the TX, which means Kafka topic name. Is a fraud is also Kafka topic name. So this is a really topic name incoming, outgoing, which is pretty much obvious to how do you send out your event data, message data into Kafka topic, or consume that message from Kafka topic as well. So when I go back to window and then just welcome page again, this is like a fraud, and then I'm just creating 2,000 transaction at the same time to check it out, some of the detected fraud data. And then you can see that all 2,000 is running on all separate virtual machine. So pretty much fast. It's a really showcase how virtual thread is fitted in the concurrent application. That's it. So it's pretty much simple. And then let me go back to slide that give some more, like some tips and tricks around the virtual thread. So you just see that I just keep saying that, oh yeah, so one annotation in Quarkus, pretty much easier to run your application on the virtual thread. That is all true. There's no secret source behind the scene. Yeah, it is. It actually. So there's the one thing you need to be cautious and care about. Why you cannot run every application on virtual thread? Because there are so many restrictions in virtual thread. Even if a really good capability, it just came out, and then there are some limitation at a time to apply for all virtual thread capability on Java ecosystem. First of all, the pinning. So whenever you use some of the library, and that library implement underneath like a synchronized block or a modular, and then that allows that doesn't allow your virtual thread to store your state information in the stack data, because whenever you virtual theoretically, whenever you hit the remote services, and then your virtual thread actually amount and then store your state data in the stack. However, so whenever you some like a native call or native API call or the synchronized block, which it doesn't allow you save your state information in the stack, which means you cannot amount your virtual thread. It's really block your platform thread as well. That's why we call that pinning. So for example, so Quarkus actually have so some of your data transaction mechanism or library, it really using this synchronized and monitor business logic. With that, even if you don't use in your application directly, but underneath the library actually use that pinning technology, and it's really go back to running on your application platform thread directly rather than virtual thread. And another thing is monopolization. It's a really long learning process. So for example, even if without remote services, sometimes your application needs to long learning computation to very complicated business logic, like a big O annotation, and it takes more than 30 seconds or even more than 5 minutes to process all business logic. In the meantime, you just hold that platform thread, a virtual thread, hold the platform thread to you to process that computation, and then so but JVM doesn't allow you waiting for unscheduled many virtual thread. So that's why I'm going to create a new platform thread to allocate a new virtual thread rather than keep waiting for unscheduled virtual thread in the meantime. So these are really not good use cases for running your application, like a monopolization application on your virtual thread. Maybe you want to try to create a new dedicated platform thread manually to align the long learning processes. And another thing is thread safety. So just imagine that virtual thread is fitting the concurrent application, which means you can actually split multiple tasks at the same time in parallel, and then combine that result at the same time. For example, Java 21 introduced structured concurrency API, which allows you have a split multiple tasks and join it again for the result. For example, you can actually like a file or multiple tasks running on a separate virtual thread, but actually each virtual thread try to change some status at the same time, but some of the application doesn't allow it to change some of the status in parallel at the same time. For example, data transaction pool doesn't allow to change the status at the same time, multiple tasks. So make sure when you run application at the concurrency level, and then not going to try to change some status, which is a really thread safe model. And then object pooling, so like I just mentioned earlier, so for the years, threads were very expensive to create it. So that's why we need to think about a workaround, how to make some cheaper. So that's the reason why we have some object pooling mechanism. Okay, we're going to create a new, rather than keep creating new platform thread, we're going to reusing existing platform thread based on pooling mechanism. That's the one of the example. We're going to create a thread local, and then you can only access some of the resources running on thread local with running on the same source code. And then, for example, some of the library like JakartaEE also use this thread local mechanism. So that's the reason we got some issue. So a couple of months ago, in a JCon Europe, I actually showcased similar demo with the same Quarkus Studio application, but I gotta hit the teeny error with the object pooling error when I using Jackson library. For example, I just already showed that I'm using Jackson extension. So, but luckily, one of my friends, like Maria Psaco, actually make the PR, and then that's already merged into that Jackson project, and then which he eventually merged into Quarkus project is at some point in the future. So with that, I don't, and then so maybe I don't need to rewrite my application anymore. So this is a really challenging for all Java developer to use a virtual thread, because you don't know every single detail underlying library technology. So some of the libraries still not familiar with the integrating virtual thread model, which is maybe that whenever you run the application with that library was third-party ecosystem, it just let you back to platform thread rather than running a virtual thread at the same time. So this is the reason why a lot of ecosystems still are not mature to run virtual thread at this moment. So here's a quick example. I just using the same to-do application running on some little bit like a benchmark test, and compared to virtual thread and then blocking application, non-blocking application, specifically response time, throughput, and container environment. As you can see here, so this is some green line is a virtual thread, and the blue blocking, and reactive is red. Every time red in a reactive is really cool, high performance and fast response time and a high throughput. And also virtual thread is pretty much good at just like a virtual thread. However, when you reach out to almost 35 or 3700 concurrency level, and then it spikes pretty much lower than performance in terms of response time and throughput. And also memory and CPU utilization at the very beginning is pretty much better than blocking application. But when you some of the concurrency level exceed like a 30,000 or something like that, it's way lower than blocking application. Even if it's going to be harder than in container environment, because the container very limited resources, and then whenever you hit a spike, there's some of the memory and CPU maximum capacity. So Kubernetes automatically scale out rather than scale in and down, up and down. So that's you always be cautious to using virtual thread, specifically inside the container environment. So let's go back to bullet point once again. So virtual thread still simple development model, which is like a super simple. You just, like, for example, Quarkus, you just put in the run on virtual thread annotation. However, the resource efficiency and concurrency level, I would say finger crossed and maybe good to have based on what is your expectation. And here's some key takeaways. So as long as you're going to use Quarkus, because Quarkus tried to integrate virtual thread as much as possible, not only database transaction or RESTful API or some messaging application. We're going to keep trying to patching, updating, get rid of like pinning, monopolization, some of the pooling issue to keep running that applications on virtual thread. And then we got some roadmap to integrate WebSocket or CDL Sync Observer as well. You can just download the new Quarkus application, getting started with it from code.quarkus.io, and then just running your Quarkus CLI and based on Java 21 and use it run on virtual thread. And then it let you pretty much easier start to Quarkus application with the Java 21 as well as a virtual thread. So I'm going to just quick ask the same question. It's literally my topic today, but I'm going to end up with a question mark here. Simple, efficient, concurrent, but it's sometimes you got to hit the carrier thread pinning or monopolization, or sometimes it's compromise your underneath library, and then you will finger crossed your efficiency level based on your concurrency expectation. So once again, if you find all demos and the relevant technical tutorial, you can just visit my YouTube channel, Bini URL Daniel TV, or YouTube handle Daniel030, and that's it. And then if you have any question around this demo and Quarkus and the virtual thread, feel free to reach out to me directly and the YouTube channel or Twitter and the LinkedIn. I'm more than happy to address your question. That's it. That's all I have today. And thank you so much for joining this session, and hope you enjoy the rest of the conference.
Yeah, thank you so much, Daniel, for your interesting input. I think there were some questions in the chat. I'm not sure if you already answered them or saw them already. If you want to have a look.
Okay, let me try to bring that up. Okay, so I can now see that. So is it fully support in Quarkus 2.16? Yes or no. So so virtual thread annotation actually available since 2.12 or something like that. But some of the dependency is not patched. So I would ask you can maybe use a race version, but some of the application like a database like a Panache or the other stuff still working under 2.16. But you gotta hit the pinning issue. But if you upgrade Quarkus to that like a race version, you don't have an issue anymore. And then second question, how the virtual thread different from the vertical concept? That's a really good question. So the vertical is Quarkus actually running on Vertex, but it's not 100% same vertical concept. We actually implement some of the part of the reactive application based on the small Unity project rather than just converting Vertex and vertical concept. So you feel like a very similar. However, maybe you could just convert or migrate existing Vertex application into Quarkus. Some of the original Vertex functionality doesn't work in the Quarkus anymore. Okay, I think that's all. I got some question, and then just feel free to reach out to me directly. I'm more than happy to keep talking and chatting about that topic as well.